Hello everyone, welcome to today's webinar. Today we're going to go over Unit 3 in Geometry, and Unit 3 speaks about circles. Before we start the webinar, I'd like to introduce myself. My name is Miriam. I'm the math instructor here at Penn. I did join the team in October 2015, and I am certified to teach math in the state of Pennsylvania since 2010. I did earn my master's degree in urban education last year. Today in this webinar, we're going to go over different topics in this unit. It's not everything that you need to learn for the exam, but these are the topics that I get the most questions on, that the exam shows that it needs more practice. So please use this webinar as a supplementary material to your lessons. You can also reach out for help, and we're going to go over this at the end of the webinar. If you have any questions, feel free to type the questions in the questions box. The raise your hand feature is not enabled in our webinars. If you have registered for this webinar, you will get a recording, whether you attend or you're not with us today. Today, we're going to go over different topics in the unit. We're going to go over central and inscribed angles. We're going to go over arcs and chords and the different facts that we learned about that in our unit. We're going to go over the arc length versus the arc measure, and we're going to learn the difference between them. Tangents, we're going to go over radians and degrees, how to change the units, and also how to differentiate between inscribed and circumscribed polygons. Before we start our webinar, I would like to go over the basic elements of a circle. I know this is elementary school, but some of us still have some confusion about the elements, like what's the difference between a chord and an arc, for example. So any circle has a center. So the center would be the center of the circle. So that would be this point here. So this is the center of the circle. The diameter of the circle is the line that connects 2 points on the circumference of the circle, but it has to go through the center of the circle. This is the diameter. The radius is half of the diameter. Example, that would be a radius. So the radius always is half of the length of the diameter of the circle. Chords, any line connects 2 points on the circumference of the circle, but it's not going through the center. This line is a chord, for example. And then arc is just a piece from the circumference of the circle. The line here just appeared as an example of an arc. We have minor arc and major arcs. We're going to go over the difference in a little bit. Also, we have angles in circles. So the little circle on the bottom here has a central angle, the one in blue. The central angle has its vertex on the center of the circle. Also, we have inscribed angles. Inscribed angles have all the points on this angle on the circumference of the circle. It doesn't have any vertex on the center, but all three, as you see, is on the circle. This is an inscribed angle. Another example of an inscribed angle in orange here. So after we went over the elements, let's then go through the facts that we need to learn in this unit about central and inscribed angles. Within this webinar, we're going to go over each topic, and then we're going to have a little practice. This practice is not graded. I do not keep track of who did get the question correct or no. It's merely given to you to assess yourself and practice the topics since we're live here together. Central and inscribed angles has a relationship between them. So let's read the facts over there and then apply them on the example down there. If a central and inscribed angle intercept the same arc, intercept meaning that they trap. So this central angle, EOD, it's central, and also the inscribed angle ECD, they intercept the same arc. They are opposite to. They are trapping the same arc ED. Then the measure of the central angle EOD should be twice the measure of the inscribed angle. Or I can state that another way. I can say that the measure of the inscribed angle, ECD, is half the measure of the central angle, EOD. Now, another fact that we have to remember always when we work with central angles and arcs is that the central angle have the same measure of the arc that this angle intercepts. So the measure of EOD in degrees is the same as the measure of the arc ED in degrees. This tip is so helpful whenever we're working with questions. Sometimes we need this little fact to be able to arrive to our answer. So let's see. On this circle O, and we always name, most of the time, we name the origin or the center of the circle O from origin. The circle O, what is the measure of the angle EOD? So EOD is a central angle. In the wording of the question, it does not necessarily have to say that EOD is a central angle, but looking at the figure, you know that EOD is a central angle. So another given in the circle is the inscribed angle, ECD. So what is the measure of this angle if both angles, they intercept the same arc? We're going to use the fact here on that box. What would be the measure of EOD? Well, to find the measure of EOD, we realize it's a central angle, given is an inscribed angle, then use the fact 2 times the measure of the inscribed angle, which is 70, will give us the measure of the central angle. 2 times 7 is 14, but 2 times 70 then would be 140. You can use your calculator if you'd like, but I would prefer if you do the mental math if the math is simple enough to be done this way. So this central angle is 140. What is the measure of the arc? This symbol is for the arc ED. So ED is an arc. What is the measure in degrees for this arc? Remember, the measure of the arc is the same as the measure of the central angle that faces the arc. Well, the EOD is the central angle that faces or intercepts the arc, then the arc will have the same measure as the central angle, 140 degrees. Any questions? Anything that was not clear on this topic? For those who just joined the webinar, you're able to ask your questions by typing the questions on the questions box. Let's go to the next slide. This is a self-check question again. Those are not graded. What's going to happen? We're going to read the question together, think about the question, and then I'm going to change my screen to give you the same question, but this time you'll be able to choose an answer. So examine the circle below and answer the following questions. What is the measure of AEC? It's an angle. So whenever a question is asking me to find something on a circle or a figure, I need to point at this angle or figure or segment in my figure. So I would know the relationships of what's asked of me with the other givens in the question. So measure AEC would be this angle. What is the measure of this angle if we know that the central angle AOC measures 80 degrees, also given an inscribed angle BDC 15 degrees? What do you think? When I change my screen, we'll give you options, but you can use simple calculations to find the answer, the measure of AEC. Okay, and Bridget is asking a question that the unit is confusing a little bit, Bridget, watch the webinar till the end. You are able to reach out for help, and also take your time studying the material. I know math is sometimes challenging, but we need to find a way to learn either math, science, or any other subject, because our goal, remember, is to earn the high school diploma. Okay, let's change the screen then. You have the circle there. I hope that you did do the calculations and find the measure of the inscribed angle AEC. And here is the question. I'm going to wait for a few seconds for everyone to have a chance to do their answers, and then we're going to go over the question together. Okay, let's do the question together. So since AEC is an inscribed angle, and this angle intercepts the arc AC. Also, we know the central angle intercepts the same arc, which is AOC is 80 degrees. That makes us use the fact that the inscribed angle equals the half of the measure of the central angle. So the measure of AEC equals half times 80, and that will equal to 40 degrees. So the correct answer is 40. 40 degrees is for this angle. Okay, let's do the second question. What is the measure of the arc BC? We have the semicircle. We now know that this angle is 40 degrees. So the question now is the measure of BC, the arc BC. Can we find the measure of BC? Look at the circle again. Look at which givens are beneficial for us to end up with the measure of the arc BC. What do you think? Okay, we have two angles, BDC and BOC. What's the relationship between these, and can that lead us to the measure of arc BC? I'm going to change my screen. I'll give you the question. You'll be able to select your answers. A few more seconds and then we'll do the question together. Remember that BC is not intercepted by the angle AOC. So if you have not selected your answer yet, think about that. BC is not intercepted by the angle AOC, but there's another central angle that this arc is intercepted by. Okay, let's do the question together. So back to our circle. Now, we know that the inscribed angle that intercepts the arc BC is 15 degrees. Well, the central angle that intercepts the same arc would be twice the measure of the inscribed angle. So the measure of angle BOC OC equals to 2 times 15. That will be 30 degrees. And now we remember that the measure of angle BOC equals to the measure of the arc BC, which is 30 degrees. So the answer is D, 30 degrees. Any questions? Anything that did not make sense or did not go along with your readings of the lesson? Okay, let's move on to the next topic. Okay, so arc measure and arc length. What is the difference? So far we have seen arc measures in degrees, like the BC was 30 degrees. What about the arc length? Well, the arc length is how many inches or how many centimeters or how many feet this arc measures. So to understand the difference, the arc measure is how many degrees the central angle extends over the circumference of the circle, and that will give us the arc measure. So whenever you see or hear the word, or if you're questioned to find the arc measure, that is in degrees or radians. The arc length is like when you extend like a measuring tape over the arc. What would that be in inches or any length unit? This is the difference. Now, how can we find an arc measure if we're given the length of the arc, or vice versa? If you have the measure of the arc, how can you find the length? Or if you're given the length, how you can find the measure? We're going to use a proportion to do that. And that proportion will be based on factual information that we know about the circle. So on the top here on that box, you will see the proportion. The proportion is two equal fractions that we know that they are equal. And we use base information or factual information on the bottom or the denominators of each fraction. And then one of the top values will be known or given in the questions, and the other one will be the unknown that we have to solve for. So the first fraction will do with length. The length of the arc CD divided by the circumference of the circle, which is the length of the whole circle. The full round of a circle is the circumference, equals to another fractions that deals with degrees. The measure of CD, that same arc, divided by 360 degrees. Remember that one full circle is 360 degrees. So based on these factual information and the givens in the question, we will be able to find the length, how many inches, how many centimeters the arc CD measures. Let's do that together. So since we need the circumference of the circle, and I'm looking at the circle, nothing gave me the circumference of the circle, but they gave me the radius of the circle. We know the basic formula for finding a circumference of a circle. So circumference C equals to 2 pi r. And r here is the radius, the red line that connects one point from the circle to the center. This is 3 inches. It's given as 3 inches. So 3 times pi is a value. It's not changed. Pi is 3.14. And then the 2 is just from the formula. So 2 times 3.14 times 3 should give us the length of the full circle, the circumference. Use your calculator. You can multiply these 3 values and you'll find that the circumference of the circle is 18.84 inches. Well, I have the circumference. I know it's 360 degrees. That's unchanged. Now I need the measure of CD. And I have the length in the question the other way. I need the length and I have the measure of CD. So this is given, CD is given in degrees, but the length is what we need to do. So let's set up the proportion with the values that we know already. So the length of CD is the unknown. I'm just going to keep it like this. Circumference we know, 18.84 inches. And then the measure of CD, Well, the measure of CD is the same as the measure of the central angle that intercepts the arc. So since COD is 35 degrees, I can conclude that the measure of the arc CD is 35 degrees. So 35, and then 360, that's the full circle. Next, I need to solve the proportion. My way to solve the proportion, I always share with my students, it's one-step way. I'm going to cross multiply and then divide, and that will give us the unknown length for CD. So length CD equals to 35 times 18.84. So cross multiply and then divide over 360. The way we're going to do it in the calculator, we're going to do 35 times 18.84 equals 2, and then divide 360 equals 2. And that will give you that the length of this arc is 1.83 inches. So from the measure of the arc, I was able to find the length of the arc. From where did you take the 2 times 3? Bridget is asking. So I think you are referring to the circumference formula. Is that right? So the 2 pi r is a formula that we know. We did not invent it. We did not discover it. It's there. It is true that the circumference of any circle is 2. So the 2 is part of the formula. And then pi is a constant. It does not change, 3.14. And then the radius is given as 3. This is a given. And that's why I have the 2 from the formula. The pi is 3.14. It does not change. And then the radius is given as 3. I multiplied the 3 values, and that gave me the circumference of the circle. Did I answer your question, Bridget? Okay, great. Thank you for your questions. So again, if you have any questions, yes, put them in the questions box and keep them relevant like Bridget is doing now. Okay, so let's then look at a self-check question on the same topic. What is the measure of angle EOB? So once we are given or asked a question from the wording of the question, because it's geometry, deals with figures, I want to point at the angle. EOB is here. In my mind, I know it's a central angle. I may have to use that fact later. If the circumference of the circle shown is 100 feet, so C, circumference equals 200 feet, that's given. And the length of EB, and EB is an arc because that symbol says it's an arc, equals to 13.9 feet. And I knew it's a length, not a measure, because of the units. The units are feet. So they must be referring to the length of the arc, not the measure. What is the measure then for this central angle? Well, in our mind, we know how to use a proportion to find the measure of the arc. But then can we find the measure of the central angle from the measure of the arc? What do you think? I'm going to leave that screen for a bit. I want to remind you of the proportion. Here goes the circumference. Here goes the 360 degrees. And here goes the angle measure or the arc measure in degrees. So measure of CB. And then the length of CB. I made it so easy for you. So all you have to do is to replace all the known values in the proportion and then solve for the unknown. Take your time and do the calculations correctly, and then I'll change my screen in a few seconds. Okay, let's change the screen again, and it will give you the question. And what is the measure of the central angle? What would be the measure of the central angle? We have the length, 13.9 feet. We have the circumference given. You don't have to use the formula, 2 pi r. It's given, 100 feet. So it saves us some work. 360 degrees is known, it's a fact. Then the only unknown in this proportion is the measure of CB. Okay, let's do the question together. So again, let's replace the values that we know and the proportion. The length is given as 13.9 feet. Circumference is given right away. You don't have to do the formula. So 100 feet is the circumference, equals to the measure of CB is unknown. 360 degrees is a full circle. Gonna solve the proportion. So multiply, cross multiply, and then divide. So 13.9 times 360 and then divided by 100 feet. That should give us the measure in degrees for CB. And then you're going to punch it on the calculator correctly and then do the division. And then you do realize that the measure of CB is 50 degrees. So the measure of this arc is 50 degrees. What would be the measure of the central angle that intercepts this arc? The same, 50 degrees. So the answer is A, or 1, which is 50. 50 degrees is the measure of the central angle. Any questions? In the exam, do not expect that the questions would be like a straightforward question. If they are, good. If not, you may have to use multiple concepts to arrive to the question. So be prepared that you want to look at the figure, conclude everything that you're able to from the givens, from the figures, from the facts that we know about circles, and then use them all together to find the solution. Next, one of the challenging topics I see, not challenging, but maybe new to us. We knew a little bit about circles, but in this unit we are going in depth for circles. So one of the facts that we will study in this unit is equal chords. If I have one circle and I have two chords, so the chords are the segments connecting 2 points on the circle but does not go through the center. So CD is a chord and AB is a chord. Well, the fact says if the two chords are equal in length, then they must intercept two arcs of the same measure. So if we read down there, if AB equals to CD, the chords, then the arcs CBD and ACB, they have the same measure. So this is just a visual representation of what they mean. So ACB, the major arc here, will measure the same arc as the other major arc that this chord makes or intercepts or divides. So it is ACB. So these two major arcs are equal because the chords are equal themselves. Also, there are other sets of arcs with equal because of the two chords being equal, which are the minor arcs. So CD will equal to AB. Now, these two equal arcs They may intersect and may not intersect, like the second circle on the right, but the fact is the same. The two arcs that these chords intercept will be equal. So the major arcs TVS and VSU, it's confusing, but with practicing you will know which arcs will equal which arc. And then also the minor arcs will equal each other. This is what basically the fact says about the equal chords. Now let's practice. In the circle shown, if the chord AB, it gave us the condition of the fact AB equals to CD, and it's not the arcs here. See the straight segments here? It means that the chords are equal. And also gives us the measure of AOB. AOB. The measure here is 65. That's given. 65 degrees. Then what is the measure of CD? CD. What do you think? We have equal chords, then they intercept equal arcs, and the equal arcs in this case is CD and AB. What is the measure of this arc, one of the arcs, CD? What do you think? Can we use the central angle measure to come up with the answer? I'm going to leave that screen with the figure for a few seconds and then switch my screen. Okay, let's do the question on the other screen, and please participate in those questions. These are beneficial for you to assess yourself. It's not graded, it's not required, but it is good to know where the points that you need to review before you go ahead and take the exam. A few more seconds and then we'll do the question together. Very simple. No real calculations, but you're just connecting facts together, and you'll be able to find the measure of arc CD. Okay, let's do the question together. So from the central angle measure, we know that the arc measure that this angle intercepts, so measure of arc AB should equal to 65 degrees. Well, since the chords are equal, then these arcs CD and AB are equal as well. So measure of AB, the arc, equals to the measure of CD, the arc, which is 65 degrees. So B, or number 2, B is the correct answer. That's it. We did not multiply, we did not add, we just used the facts that we know already about circles. Any questions? Anything that was not clear? Let's move on to the next topic. Well, now we're going to deal with two intersecting chords. They do not have to be equal, any intersecting chords, but the chords have to intersect. And if that happens, two things will happen along with that. So if any two chords, like A, B, and C, D in the figure, in the same circle intersect. So the condition here is that any two chords intersect, then the corresponding chord segments are proportional. And what do they mean by the corresponding chord segments? Chord segments are AE, EB, CE, and ED. They have a proportion. They are similar. If you remember from Unit 2, we went over similar segments. There is a proportion exists between these four segments. If that happens, that any two chords intersects, then we can translate that proportion by saying that the length of segment AE times the length of segment EB, AE times EB, that comes from the same chord, equals to the length of CE times the length of ED, comes from the other chord. Let's apply this fact. The circle is given if the segment AE is 4 inches, that's given. So this is 4 inches. CE is 3 inches. And BE is 10 inches. Of course, they're going to ask about the length of ED. So since we have two intersecting chords, we will use that fact directly. So AE is 4, AE is 4, times EB is given as 10, should equal to CE, and CE is given as 3, times the unknown segment, which is ED. Let's rewrite the equation. So 4 times 10 is 40, equals to 3 ED. So the only variable that we have on this equation is ED. It's one variable. So using basic equation solving methods, we just divide over 3 and divide over 3 both sides to isolate the variable ED. So 40 over 3 will give you 13.33 inches equals to, that's 1 equals to ED. So the length of the segment ED is 13.33 inches. Any questions? Let's do a practice question on this fact. The same thing. So they are giving you two intersecting chords. They did not say that they are equal, just intersecting chords. They give you segment lengths. So they are saying the SU is 9. It is a good habit to label your figure with the givens, so you're able to look at the figure and relate everything given, so you're able to use it. TU is 3, that's given. UR, that is 7. What would be the length of segment QU? I'm going to remind you with the proportion that we just went through. It should be SU times the other segment from the same chord, UT, equals to the other two segments multiplied from the other chord, QU times UR. You have 3 given and 1 unknown. You can continue on from there then. Okay, let's switch the screen to the question, and you'll be able to choose your answer. So you have SU is 9 centimeters, TU or UT is 3 centimeters, UR is 7 centimeters. What would be the length of QU given that they are chord segments and the chords are intersecting? Okay, let's do the question together. So again, we have the proportions set up. A proportion can be 2 equal fractions or 2 equal products. So SU times UT is a product and equals another product, QU times UR. So SU is 9, that's given. I did not conclude it. It's just given right in the question, times UT is 3 equals to QU is unknown. That's the unknown segment times UR, and UR is 7. Again, simplify the equation. 9 times 3 is 27. You can use a calculator, but 9 times 3 is 27, equals to 7 times QU. Now 7 QU is the variable, isolate the variable by dividing over 7 and dividing over 7 the other side to keep the equation balanced. 27 over 7, it will give you that QU equals to 3.8 centimeters. So the answer would be, it should be 3.8. None of the answers actually is correct. So that should be 3.8 actually. So that is C. And that's the reason none of you answered the question, I just realized. So 3.8 is the answer. Any questions? Any questions on how to use the proportion or how to know that this is the proportion that we have to use? Okay, let's move on to the second fact that draws from the chords being intersecting in the circle. Another fact is that we're able to find the angle measures forming from intersecting the chords intersecting. So X, U, Z, the angle, and W, U, Y. These two angles we're able to find the measure for. Also X, U, W, and Z, U, Y. So the rules say that the two angles, the two vertical angles, XUZ, WUY, should equal to the half of the sum of the measure of the two chords, the two arcs that they intercept. So if I know the measure of XZ, the arc, and WY, the arc, I can add them, take the half of that, and that will give me the angle measure of this angle, which is equal to actually the measure of this angle. Remember, they are vertical angle. Vertical angles, they have the same measure. That's why the two angles have the same measure. The same way, if I want to look at the other two forming angles, like XUW and YUZ, these two angle measures will equal to the half of the sum of the arc XW and ZY. Let's practice the facts and see how we're gonna find the answer for the question. F, the arc XZ, label the figure. So XZ is 15 degrees, that's given. And arc WY, so WY is given as 45 degrees. Then what's the measure of angle XUZ? XUZ is this one here. Well, two intersecting chords, so right away, because they're asking for an angle measure that is forming from the intersection, I'm going to use the facts. And the fact says that the measure of angle XUZ should equal to the half of the measure of the two arcs intercepted. So XZ would be one of them plus the other arc WY. Everything is given in this question. I have just to plug in the numbers half times. XZ is given as 15 degrees plus WY is given as 45 degrees. So we need to do the order of operation correctly. We are not going to multiply half times 15 and add 45. We actually have to do the operation inside the parentheses first and then multiply times half or divide over 2 is the same thing. So half will remain outside. 15 and 45 is 60. Half of the 60 will give you 30 degrees. So this angle XUZ is 30 degrees. Any question before we go to a self-check? Okay, let's go over one of the practice questions on the same topic. Again, a circle, two intersecting chords, and there are some angles forming from that intersection. F, the arc measure SR equals to 80. SR equals to 80 degrees. QT equals to 35 degrees. And SQ equals to 145 degrees. What is the measure of the angle TUR? So they're trying to know the angle measure of this one here. So remember the rule, the measure of angle TUR should equal to the half of the sum of the intercepted arcs. So it should be the sum of SQ and the arc measure of the other one, which is TR. Well, SQ we have, TR we do not have. How can we find the arc measure TR? Remember that the full circle is 360, and we are given 3 parts on the circle, and there is a remaining part, which is the arc measure that we need. How can we arrive to the measure of TR knowing the other arc measures? What do you think? I'm going to leave that figure for a few seconds. Think about how can we find the TR, because we need it for the formula. Without it, we cannot find the angle measure TUR. Okay, let's go to the question and try your best to select the answer that you think is right. Here you go. Okay, let's do the question together. So again, this is the formula, and we use that because we know the 2 intersecting chords, but we are missing the TR, the measure of arc TR. We know that the full circle is 360 degrees, minus then the other arcs that we know. TR will make up the one full circle. So minus the sum of the arc measures that we know, 80 plus 35 plus 145. So we're going to add the 3 values first and then subtract that from the 360. So 80 plus 35 plus 145, and then subtract that from 360. You can use a calculator if you'd like. You can do it manually if you'd like also. For me personally, if we're learning about circles and chords and theorems and facts, I would not bother myself or distract myself doing the addition by hand. So I would just use a calculator. So that will give you at the end 100 degrees. That would be the measure of TR. So TR now is 100 degrees. So we know now TR, we know SQ. Take the half of that, that will give you the measure of angle TUR. So the measure of angle TUR equals to, follow the formula on the top, half times SQ is given as 145 degrees. And then you're going to do, I'm just checking the theory here, 1 second. Okay, it is addition. I just thought it's subtraction, but it is addition. We are correct. So we add, because there's another theorem that we subtract. So still we're going to add TR. Now we know it's 100. So now take the half of the sum. 145 plus 100 is 245. Half of that will give you 122.5 degrees. So this is the measure of this angle, and this angle will measure the same thing, 122.5 degrees. So the answer is C. Any questions on this topic? Anything that was not clear? Okay, let's go over tangents. So a tangent of a circle is a line that intersects the circle at one point. So for example, the line or the segment AE is a tangent because it only intersects the circle at one point A that we call the point of tangency, and that's why we call AE a tangent. The same way BE is a tangent because, again, B is the only intersection point between the circle and the line. When we have a circle, two tangents that meet outside the circle at a point, in this case it's E, some facts follow. So if that happens, one of the facts that we know is that the two tangents are equal in length. So AE should equal to BE. That's one. Two, we also are able to find the measure of the outside angle E. And that is given by this fact. Half of the difference of the measure of the major and the minor arcs. We're going to go over an example. And number three, it follows that the radius AO is perpendicular to the tangent. The same way OB is a radius, it should be 90 degrees with the tangent. Let's practice to demonstrate how we can use these facts. What is the measure of angle E? Again, E is where the two tangents intersects outside the circle. So in that case, if I have a figure like this, I know it's tangents, I know that they're meeting outside. So in my mind, I'm going to choose this theorem to go for. So the measure of angle E equals to the half of the difference of the two arcs, the major and the minor. Now, given in the question that the major arc, the mean ACB is the major arc, so that is 210 degrees. So I know ACB. ACB is 210 degrees minus the minor arc measure AB. Again, a full circle is 360. I know one of the arcs is 210. So subtract, and that will give you that the minor arc is 150 degrees. So now we know that AB, the minor arc, AB in the formula is 150 degrees, minus 150 degrees. Now all I need to do is to do the expression, evaluate the expression the correct way, the parentheses first, so subtract, and then times that times half, or multiply it times half, or divide it over 2. It's the same way. So it's going to give you half times 60, and that will give you 30 degrees for the angle E, 30 degrees. Any questions? Anything that was not clear on that question? Okay, now what is the angle measure of AOB? AOB, this one here, what do you think? Well, AOB is a central angle. And we know that the measure of the central angle equals the measure of the arc that this angle intercepts. Do we know the angle measure, the arc measure AB? Yes, it is 150. So the angle measure, the central angle, would be 150 as well. That's it. Okay, we're going to go over self-check on the same topic. These 3 questions on the same figure. So examine the circle O, then answer the following questions. Measure of the arc AEB. Examine the figure. Some givens are there. Central angle is 70. They are asking for the measure of the major arc AEB, this one. Do we know that? Well, the central angle is 70. That means that the arc measure AB is what? And from there, are we able to find the measure of AEB? Think about it and choose one of the answers there. Okay, and here's the question on the other screen. What is the measure of the major arc AEB? What do you think? Is it 290 degrees, 70 degrees, 140, or 160? Okay, let's do the question together. So again, it's asking us to find the measure AEB. Well, I know that the central angle is 70, then the measure of AB will be 70 as well. So again, a first circle is 360 minus the 70, and that will give us right away the arc measure AEB. And that would be 220 degrees, and that would be answer A. That's it. Very simple. Next question on the same figure. Again, the central angle is 70. So far, we know that this is 70 degrees, and that was given as 290 degrees. We found this out by the subtraction. So now they're asking about the measure of ACB. Where is that angle on the figure? This one. ACB is the outside angle where the tangents meet. What is the formula that we said we are able to use to find the measure of this angle? Okay, I want to remind you of the fact that we talked about the measure of ACB because that's the outside angle, the intersection of the two tangents of the circle, half of the difference of the major and the minor arc. So that it would be AEB, the bigger one, the longer one, and then minus the smaller one, AB. Do we know the angle measure, the arc measure AB and AEB? You can then do the calculation and choose one of the answers. Okay, I'm going to change my screen to give you that question so you're able to also select your answer. Okay, let's do the question together. So again, we're going to do half times the major arc is 290 minus the 70. Do the subtraction first and then take the half of that. So half times 220 will be 110 degrees. So B is the right answer. This angle is 110 degrees. Any questions? Anything that was not clear? Okay, the last question on this figure would be very simple question. What is the measure of OBC? Two tangents for the circle, and OB is a radius. What do you think? No calculations involved, just facts. OB is what to CB, given that CB is a tangent and OB is a radius. So I'm going to give you the question right away with the other screen since it is easy to just pick the answer. What is the measure of this angle? Okay, let's do the question together. So again, from the fact that these two tangents intersect at one point outside the circle, that would make the radius perpendicular to the tangent. So it is 90 degrees. So the answer is C. That's it. Okay, let's go through the next topic that I was asked to cover, which is radians and degrees. So radians is another unit for measuring an angle. Like think about centimeters and inches. They are different units of measuring length. The same way, we have different units to measure radians. Radians usually are used more in trigonometry, but we're going to just go over the basics, how to convert a degree or degrees or an angle that is measured in degrees to radians. And again, we're going to use a proportion because we have a factual information that we know that 1 radian is equivalent to 57.3 degrees. If you're given the angle measure, for example, in radians, then you have one unknown, which is the degree measure of the angle. Cross multiply and divide, and that will give you the unknown value. So let's do the question and apply that concept. What is the measure of angle A, any angle A, there's no figure there, in radians if the angle A measures 105 degrees? Again, I'm going to do the proportion because we have reference information we can use. 57.3 degrees is equivalent to 1 radian. Now, we need the measure of angle A in radians, so that is unknown, but the degree measure is given. So again, a proportion, one unknown, cross multiply, and then divide. So the measure of angle A in radians equals to 105 times 1, which is 105, over 57.3. And its simple calculations 1.83 radians. So 105 degrees is equivalent to 1.83 radians. Any questions? Okay, let's do another way. So what if the measure in radians is given and they're asked us to find the equivalent degree measure of that same angle? We're going to use actually the same proportion, no change to the proportion or the rules. So we know it's 57.3 degrees equivalent to 1 radian. And this time they gave us it's 4 radians. What is the measure of angle A in degrees? So again, cross multiply and divide. The measure of angle A in degrees equals to 4 times 57.3 degrees divided by 1, which is the same as 4 times 57.3. Use your calculator, and that will give you 229.2 degrees. So 4 radians is equivalent to 229.2 degrees. Any questions? Okay, it's really simple. So let's do one last practice question in this webinar. What is the measure of angle ACB? Okay, ACB is where? ACB is an inscribed angle. What is the measure of this angle in degrees? I'm sorry, in radians. So the question is asking you to find the measure in radians if they give you the measure of the arc AB in degrees. So AB is 65, and the inscribed angle intercepts the arc AB. There's another central angle there. Can we find the angle measure C here in radians? Take your time. Think about that. Relate the inscribed angle and the central angle measures given the arc measure. What do you think? Okay, so the arc measures 65. What would be the measure of the central angle? I'm going to give you this 65. Now you need to figure out the inscribed angle measure that intercepts the same arc as this central angle that measures 65. Is it half or twice the measure of the central angle? And from there, you're able to use the proportion and then find out the measure in radians. I'm going to leave you with a figure one more time and then change the question. Okay, here's the question. What is the measure of the inscribed angle? Okay, let's do the question together. So again, we need to remember that the measure of the inscribed angle ACB equals to the half of the measure of the central angle that intercepts the same arc. So measure of AOB, and that be half times 65, and that will give you that the angle measure C here would be 32.5 degrees. The question though is asking for the angle measured in radians. So there is another step that we have to do, the proportion. 57.3 degrees is equivalent to 1 radian. That is a fact that we know. We need the angle measure C in radians, but we know the degrees, 32.5. Solve the proportion, so multiply then divide the angle measure C or ACB in radians equals to 32.5 times 1 radian divided by 57.3 degrees equals to, use your calculator of course, and that would be 0.56 radians, and the answer would be C. That's it. Any questions on this topic? Any questions on changing radians to degrees or degrees to radians? The last topic I want to go over, because for some reason, most of the students who took the exam did not know the difference between inscribed polygons and circumscribed polygons. So I thought just to bring that screen here, just to give you like a quick note on how to tell the difference. So in the first figure on the left, you have the polygon is inscribed. So the polygon is inside. So remember that, inside, inscribed. So the polygon, because it's inside the circle, the vertices of the polygon is on the circumference of the circle. That makes the polygon inscribed in the circle. Or in the same figure, we can say that the circle surrounds or circumscribes the polygon. The second figure, which is on the right, it is the other way around. Now we have the polygon circumscribes the circle. The polygon surrounds the circle. So the circle, if you see it's inside the polygon, each side of the polygon is a tangent to the circle. So again, in this case, the polygon would be the outside figure. We call it circumscribing the circle. Or if I want to speak about the circle, I will say that circle is inscribed inside the polygon. That's it. So that was my last topic as far as math. We did go over lots of topics: tangents, inscribed angles, central angles, chords, facts about arcs, everything that I felt the exam showed that we need to go over that again. We did find the arc length versus arc measure. We did do radians in degrees, and also we just saw the difference between inscribed and circumscribed polygons. How to study for the exam. Of course, you want to read the unit. Of course, you want to do the reading. Do not depend on the memory of middle school or elementary school of these things. We need to refresh your memory. We need to read. You need to do the practice questions or discover more questions provided in the lesson. They are meant to give you some practice in the exam. They are not graded. They are not required, but they're expected to be done as part of the lesson. So when you go and take the exam, you're familiar with everything in this exam. The answer key for those questions, the practice questions or discover more, are given for a reason. Because when you do the questions and find the answer, compare it to the answer key we give, and then you decide if you need more help on this topic or you're good, you're ready for the exam. You are able to reach out for help different ways. You can call from 9 to 6 Eastern time on weekdays. You are able to schedule an appointment with a teacher assistant or an instructor using the link on the screen. If you have a brief question, you can text message, and you can text message this number and type learn. That will come to the education department. Also, you are able to email or chat your questions. So from your student portal, you can click on Help Center, or you may have this kind of account and click on Help and Support. Both accounts provide the same functionality. It just we have changed things around. So follow those steps that corresponds to your account. You're able to either email or chat if you'd like. And at the end, I want to thank everyone for attendance and participating in this webinar. There is a short survey, 3 questions only, to give me a feedback on how I did in the exam, in the webinar, I'm sorry. You are able to do the survey if you did not attend and if you have received the recording instead. So I appreciate your feedback. If you have any questions before I leave, you can type them in the questions box. I'll be happy to answer them. Okay, I wish you all the best in the exam.